Welcome back to Empower Yourself. Today we will be learning about the statistical tools that are used for the preparation of Apqr. So, statistical tools for Apqr preparation. The statistical tools include 3 sigma calculation, Cp and CpK. Three sigma calculation. Here we have plus 3 sigma as well as minus 3 sigma calculation. The formula that is used for plus 3 sigma is average plus 3 into standard deviation. Minus 3 sigma, average minus 3 into standard deviation. So let us see how we can calculate the 3 sigma calculation. Here is the batch number. This is the X test parameter and this is the Y test parameter. So my batches includes the number of batches are 10 and the X test parameter limit is not more than 0.10 and Y test parameter is not less than 1.0%. So for all of these 10 batches, I'm gonna take the average, standard deviation and sigma calculation. So these are the results that I've achieved or that have been obtained for the 10 batches, and I'm going to take the average, standard deviation and 3 sigma value for all these 10 batches. Let us see for average. The value that I've got for X parameter is 0.04 and the standard deviation which I got is 0.02. And by including the value for plus 3 sigma, I got 0.09. So here in this case, as we have seen that we have plus 3 sigma as well as minus 3 sigma. So plus 3 sigma is calculated or used or generated for the test parameters whose limit is starting with not more than. So in this case, we are going to go with the plus 3 sigma. And for not less than, we are going with minus 3 sigma range. And if the test parameters who is having both the limits, for example, not less than as well as not more than, then we have to consider plus 3 sigma and minus 3 sigma as well. So here is the formula how we can calculate. So we can get the functions from here. We can select the function from here and we can get the results by clicking onto the average, standard deviation. So the formula that we have seen is plus 3 sigma and minus 3 sigma. So the value how I got is, so this is how I generated my value for plus 3 sigma. So here we have to go with is equal to B12, that is my average. So here if we see is equal to B12 plus 3 into B13. So I got the result of 0.09 for the X test parameter. So B12 is my average. So as I'm going to take plus 3 sigma, I included plus here and 3 into standard deviation is my formula. So 3 into standard deviation is B13. So I got the result of 0.09. In the same way, we can apply the same formula here as well. But here in case, as we are specification is not less than 1.0, we need to apply minus 3 sigma value. So we are applying minus 3 sigma value over here, and I have got my sigma value as 6.6. So this is how we calculate this 3 sigma value, and these 3 sigma values will be considered as the OOT limits for the particular year, and those limit will be used to the succeeding year. So let us see the Cp and CpK values. So Cp, what does that mean? Cp is process capability and CpK is process capability index. So Cp is also called to be PP, that is process performance, and CpK can also be called as PPK, that is process performance index. So why we have to do Cp and CpK? So here it says that Cp is process capability. So when we calculate and when we get the results of Cp, we can say how much capable my process is and how robust my process is. And this indicates the long-term achievement or the quality of the process. And CpK is process capability index, which is a short-term achievement, and we can justify the quality of the product in the short term by using CpK, and based on this we can go to the further extent that my process is able to produce the quality and it is able to produce in a constant trend. So this is how we define them. Let us see the formulas and how we calculate them in our daily preparation of Apqr. So CpK, it can be used for the single limit. So the formula for single limit having the limit as not more than. So when we have limit as not more than, we can use the following formula. USL minus average divided by 3 into standard deviation. So here USL means the upper specification limit. For example, my upper specification limit is not more than 0.10. Then I have to take 0.10 minus the average that I have got divided by 3 into standard deviation, which I got through the calculation. CpK limit, that is single limit. So CpK is calculated mainly for the single limit as well as to the upper and lower specification limit by using these formulas. So whenever my limit is not less than x, then I have to take the formula as average minus LSL divided by 3 into standard deviation. So here we are going to take the average and minus lower specification limit divided by 3 into standard deviation. This is how we are going to use the formulas to calculate the CpK values with not more than and not less than limits, as well as the Cp when upper and lower specification limits are being provided, then we have to go with the calculation for Cp as well. So this is the formula that we will use for the calculation of Cp, that is USL minus LSL divided by 6 into standard deviation. That means upper specification minus lower specification divided by 6 into standard deviation. So here we can see USL is upper specification limit and LSL is lower specification limit. So these are the formulas that we are going to use to calculate the Cp and CpK while preparing Apqr. Let us see how we are going to apply them through Excel sheet or through the software that we are going to use. The batch number, X test parameter not more than 0.10%, Y test parameter not less than 1.0%, Z test parameter not less than 98.0% weight by weight, and not more than 102.0% weight by weight. So these are the limits that we are going to use, and here we can calculate the Cp and CpK values for 25. Minimum of 25 batches are required to calculate the Cp and CpK calculation, and we can go with more batches as well, but the minimum batch required is 25. So here I'm gonna apply all the formulas that I've discussed earlier, like average, standard deviation, plus 3 sigma, minus 3 sigma, upper specification limit, lower specification limit, CpK minimum, CpK maximum, as well as Cp. So this is how I'm gonna apply it to all, and I'm gonna generate my results. So these are the averages that I got for the 3 test parameters, and these are the standard deviations that I got for the 3, and this here, as the test parameter limit is not more than 0.10, I'm going to calculate only plus 3 sigma. And here, as it is not less than 1.0, I'm gonna take the minus sigma. So this is how I calculated the plus 3 and minus 3 sigma. As I'm having plus, that is not less than as well as not more than, so I'm gonna generate two results here, that is plus 3 as well as the minus 3. So this is how I applied the formula and I got the results. So I just want to go with the Cp and CpK. So as we have learned that for not more than cases, we are going to apply the upper specification limit. So I've just kept my upper specification limit here, and this is the limit that I got for the upper specification limit. That is, I used upper specification limit minus average divided by 3 into standard deviation. So I got the result as 0.10. For the lower specification, I applied the formula as lower specification. So that is average minus LSL divided by 3 into standard deviation. That I consider it to be this limit. And here, as I'm having minimum as well as the maximum range, so I'm going to take minimum as well as maximum, both the cases, and the Cp value. So I applied the formula and I got the result over here. So what is the purpose and need of all these things? Why Cp and CpK values are required, and what is the necessity to calculate, and why we have to represent it? So we can see the result that we are getting here. So based upon the result, the CpK limit over here, the CpK limit over here, the CpK limits and the Cp limits, whatever the results we got, there is some interpretation, and these values have some importance as well. Let us see the importance of them. Interpretation of Cp and CpK values. So if an organization has a CpK limit of 1 to 1.33, this is my CpK criteria that have been applied by an organization. Whenever I receive the CpK value as is, the CpK or PPK value is less than or equal to 1. What it defines? So it defines that my process is not capable. So assessment required to identify the cost to improve the process, the method, or the specification. That means if it falls below 1, my result is, for example, that is 0.09 or 0.98 or lower than that, then it clearly says that whatever the batches that I've been manufactured during the year are not within the standards or within the specifications, and they are not producing as it is required. There may be chances of deviations, or the quality is not meeting, or OS, OOTs, or some quality events have been observed to the product. So there is a necessity that it has to be assessed so that we can identify the root cause, or we can improve the process so that we would achieve the process that is meeting all the requirements without any defects. So CpK or PPK is between 1 and 1.33. If we observe the CpK limit between 1 and 1.33, we can say that process is able to produce products within the specification limit. So we can say my product is giving the results within the specification limit that has been established and that has been designed. But it is not that excellent or with good quality. We can say if my CpK or PPK is greater than 1.33, if my limit is above 1.33, we can say my process is excellent, process is consistent and capable to reproduce results within the predetermined rate. So this is how we can interpret the results that we got after the calculations, after applying the formulas, and we can know how our process is. The CPE limit. If the CPE limit is not less than 1.1, then the same criteria will be applied. We can, if it is less, we need to give the justifications, and we need to look after the assessment, and we need to identify there are any improvements that is needed to the process or the method or the specification limit, and we have to apply it further. The basic idea is very simple. You want to manufacture the product too, that it has to be centered over the nominal desired by the design engineer. So we can say that my product or the product that is being manufactured by the organization has to give the better quality and yield. That is the main idea. So to achieve all those things, we have to see that our process or the process that has been manufactured by the organization or the manufacturer to be aligned in the center than to the lower extent or to the higher extent. So that is why the CP and CPK are important. This CP and CPK will show how our process is aligned, whether it is aligned to the lower areas or to the higher areas, or whether it is positioned in the center giving all the quality results. So to know all those things, CP and CPK are very important. So here we go with a spread narrower than the specification limit. So our process should be narrower than the specification limit that has been established. So we should not be on the lower side, or we should not be on the higher side where there will be a threat to the quality of the product, whether it could be the OS, or whether it would be out of specification or out of trend, or it could be a deviation in the product. So to avoid all those things, we have to see that our product is being centered and spread narrower than the specification width. So here we can see that Cp helps to measure whether the process spread is narrower than the specification width. So the Cp helps to identify the process spread is narrower than the specification limit. How much my process has spread, whether it has spread towards the lower side or whether it has spread to the higher side. So we can get the idea from Cp. CpK measures both the centering of the process as well as the spread of the process related to the specification width. Here it says both the centering. Centering is the main concept of CpK and the process capability. So centering of the process as well as how much it has been spread towards the lower specification as well as to the higher specification within the specification width that has been designed by the design engineer. So this is how we can know what Cp and CpK does and how it helps us to identify the quality of the product. Let us see. To understand, here is some of the picture that I am going to explain it. This is the lower specification limit and this is the upper specification limit. So after the manufacturing of the product, this is the actual product spread. So my product is spread. My product is being centered. So we can see it is in the center, not towards the lower side, not toward the upper side. So we can say that my process is centered and it is able to produce the quality without any defects. If it is towards this lower side, we can see and we can say that my product quality is not meeting properly. And if it is towards this side, the peak that is obtained is towards the upper specification limit, then it is also saying that it is not centered and it is having some defects in the process or in the quality or in the critical areas of the manufacturing process. So this is how it will be interpreted. So this is my allowable process spread. So here CpK is this, how my process is being spread. So it will show the spread of the process. CpK will define the centering. This is the center. We can see that this peak is in the center as well as how much it has been spread. So centering means this is the mean. So if we divide it this way, this is centering of the process as well as how much it has spread towards the lower side and how much it has spread to the upper specification side. So we can calculate both the thing centering as well as the spread by using the CpK value. High CpK, you will be producing fewer defective parts. So if we have the CpK limit more than 1.33, then we can say there are less defects or less quality dissatisfactions or quality failures observed in the product. So if it is having high CpK, you will improve your product performance as well. So to perform CpK or Cp, we have to check this process stability. If the process is stable, the short-term behavior of the process, that means during the initial runs, will be a good predictor of the long-term behavior of the process. So this helps in the long-term behavior as well. So that's why I've said that CPK helps in knowing the behavior of the product in the long-term cases, that is CP. So process behavior, both short and long-term, is characterized by the average and standard deviation. So whenever the standard deviation as well as the average are within the limit and they are constant over time, then we can say my process is behaving well. So process is stable when average and standard deviation are constant over time. So we can say that my process is stable based upon the consistency of the average as well as the standard deviation that has been observed during the preparation of Apqr. So process stability has major impact upon the process behavior and the quality of the product that is being achieved. So let us see a very good example which I've seen and which I've learned from this a lot. So here is my first picture and here is my second picture, and we can just simply make it into the mind as well. If we see the size of the car that has been parked in the garage, there is very lesser space over here and we can observe lesser space on the both sides. So during the parking of this car, as there is no space or less space availability, it can damage some of the parts on either side. So we can relate it to our process as well. If my obtained results are broader, that is my results are towards the lower specification limit and my results are towards the upper specification limits, so we can get the products with some defects. So there are the major chances of getting a defective car parking. In the same way, my product, the quality of my product would be defective when it is towards the lower side and towards the upper side. So if a person is learning the car driving and the space that has been more and the car is very, it is very good and it is positioned in the center, so there would not be any damages to the car on either side. And it could, when it is positioned in the center, we can see there is a lot of space over here on either side, and there will not be a chance to hit the either side of the garage, but it would be positioned in the center. In the same way, our process has to be there. So this is positioned in the center and it shows that it is being in the center and it is equally distributed, and there will not be any chance of hitting on either side, and there will not be any chance for dents or any cracks upon the car. In the same way, our product should be centered so that it will not be towards right or towards the left, so that it the quality of the product is maintained and it is well positioned in the center and we are achieving the quality products. So this is the illustration that I've learned and I hope this will help you too. The final aim is that our process has to be centered and it has to be equally distributed and it has to be narrower than the specification width. Hope you have learned something about the statistical tools that are used in the Apqr. Share your thoughts and let me know your ideas so that it will be helpful to you and to me as well. Thanks for watching and learning.